This is a workshop on technology evolution in blockchain. This will be conducted by Metaverk. And on behalf of Metaverk, this will be done by Mr. Rohit Tandon. May I request you to please join us on stage?
Good evening, guys. This is Rohit. I'm head of products with Metaverk, and I'll take this session on the evolution of technology and blockchain. I'll particularly be very specific on the technology and the blockchain aspect of it. Just to give a perspective, I've got about 20 years of experience, so I've seen a lot of shifts in technology, and we started with Microsoft-based technologies back in 2000, and then it all shifted from a web application to a mobile application, and then now we are into the verse of AI and 3Ds and metaverses there. Now, when we talk about evolution of technology, technology goes back decades, millennia there, when there were small things that were being worked upon, and then they were developed and then enhanced and evolved. That happened there. So that's how the evolution happened. Very smaller things, paths pave ways for very bigger things that we use today, that we are used to taking it for granted. Slide change, please. So the presentation is basically into introduction, then we'll quickly touch base on the evolution of technology, then we'll talk about the blockchain, what blockchain is, and then how what is the rise of the blockchain, some of the real life use cases that we have seen which are pretty successful, pretty much being used by the industries right now. And like everything, it has its own challenges and and solutions that we are there, and then conclusion and questions and answers around. So you feel free to ask any questions there. All right, slides change, please. Thank you. So technology has transformed the way we live and work, right? And then not only blockchain as of now, but any technology, any piece of device, any piece of software, hardware that we use has literally transformed our way. Everybody has mobile phone in their hands right now. 20 years back, it was just a dream. When 1999, 98, the mobile network started cropping up here in India. We used to go for places where we used to see how a mobile device would look like, we would hold it, we would use it, and now it's a common thing. Similarly, we have augmented reality, which is next platform. The augmented reality, we see that a lot of people are coming to our place, and they are wearing that glasses, and they are seeing how does the future may look like. It's more interactive. Similarly, the blockchain is another aspect of the technology revolution, where you now hold your own data, and I'll come to that in a while, what blockchain is and how can you hold your own data. But moving forward, we are trying to explore the businesses and leverage, what is the power of blockchain, how can you control your own data, your own consumer data there. And it does also bring the transparency into aspects. So when we talk about transparency, I'll spend a few seconds on the transparency part here. So as of now, we have known the technology. It is, I would say, it is not completely transparent, right? We don't know what is happening at the back of it. For example, if we let's say if we talk about our emails that we use every day, we are used to seeing our emails, and then we reply, but we don't really know what exactly is happening with our data, right? There has been a lot of privacy and security concerns, as we say, and right now what happens is maybe there are chances that your data is being shared by a lot of different companies, and also with a lot of different vendors. They use your data, they use your patterns of your emails, to target you there. So there is least amount of transparency as we see there. You go to Facebook, you go to Instagram, and then you post something. You are posting it in your own account, but it is actually available for everybody else there. and then your friends, your relatives can see you, but there are other elements that can use your data. For example, ChatGPT has been in news of lately as one of the applications, and there has been claims that ChatGPT is actually trained on Twitter, on the Twitter data. So all the tweets that the whole world is doing is one big database for the learning algorithms that ChatGPT has. So there is no transparency. When you put on Twitter, you don't know what that data is going to be used for, right? Is it going to be used for their profits? Is it going to be only kept for you there? Similarly, when we discuss about securities, it's again one of those aspects that these are all central applications that we have. We don't control anything. We can't say whether we want to have this data being placed for a certain people or not. Once we post it on these platforms, we are at the risk of their data. There has been many data breaches that has happened of lately. If you have seen that, customer data getting leaked from the databases, and that is because these are all centralized applications, as we say, where these companies, they have their own applications and they have their own databases. They manage the security on your behalf, and there can be many lapses that happens. And then we'll look into the real life examples of how companies have successfully implemented blockchain, in what sectors they have been pretty successful, and how they have gained the competitive edge. The goal is to understand the potential of blockchain as a technology, and how can it actually drive the business there. A slide change, please. Right, the next one. The technology has transformed business for centuries. We all agree to that, right? And this is where we are sitting right now here. We have everything available at the palm of our hands, whether it is our banking accounts, whether it is talking to someone who's sitting miles and millions of miles away from there. It's all technological revolution that has been able to achieve that there. There has been industrial revolution that brought major advances, particularly into manufacturing, transportation, and communication. We all agree. Even a new evolution is into electric vehicle space that we see. Lot of things are being developed there. Then there has been mobile applications, social media, and other digital technologies that transform the personal and the interpersonal and the business operations there. Now, in today's world, the businesses actually rely on technology-driven innovation for efficiency and growth. Whether it is your digital marketing, whether it is your social marketing, whether it is your even for us, if we have to go and find something, we all go to Google, and Google is just a technological marvel that has been developed there to work there. So before next slide, please. So before we move on to the rise of the blockchain, I'd like to touch on what are the phases that we have all been through and you all have seen that, must have seen that. So blockchain is part of, as we call it, Web 3.0. And before we go into Web 3.0, let's quickly touch base on what was Web 2.0, or for that matter, what was Web 1.0 there. So let's start with Web 1.0. Web 1.0 was the era when we were only the takers. When I say we, I'm talking about myself as the consumer here, where I would go to the computer, and I would just consume the data. When I say consume the data, I would say reference to sites like yahoo.com back in 90s, reference to portals like rediff.com, where I can just go to those portals and I can only read. And what I can read is what they provide the data set to me, right? I cannot say whether it is right, whether it is wrong. I cannot participate in that there. So that was a time of Web 1.0, and we all also have heard that, let's create a website so that we can get more people, right? Our catalogs can go international, and that was the part when in 90s and 2000 we all used to talk about, let's quickly come up with a website, right? We'll get more work, we'll get more business, we'll get more interaction there. And And that was when we would build something what we thought or what we want that site to be, right? That was Web 1.0. Nobody can say anything, they cannot participate in that. Then comes the era of Web 2.0. Now that is where we could interact, right? And the sample and examples of those interaction would be, let's say, Stack Overflow. All the developers of the world goes to Stack Overflow, and it's a platform where people would post their problem and then people would solve their problem as well. Similarly, we have Reddit, then we had forums, and we had chat applications where we could go and then we could collaborate, we could work with people there. That was the era of when Web 2.0, and that is when, you know, also the banking sector started coming in, where you can now interact with your bank, you can pay the money. But again, you know, you don't own any of it, right? So even if I put a solution on Stack Overflow, it's not something that I can own it, right? Once it is on the Stack Overflow, it is always on the Stack Overflow. Or if it is a Reddit or a Medium part, it is always there on those portals. I cannot go and say that, oh, this is mine, I want to take it off, or I don't want to put it over there. Maybe I have an option of deleting it or hiding it there, but still, once the content is gone to those portals, it is their data. You don't own it. Then came the era of Web 3.0, where we are now living and breathing. In this, we own the data. When we say we own the data, we are talking about something that we can control, right? No central authority has a complete control over it. And for example, banking is one of the most apt example. I think everybody talks about it. I'll try to elaborate a little bit more on that part of it. So when we interact, when we send money to one account to another, we don't own the money, right? We are simply using that money, and they reside with the banks in their servers, in their accounts there. We simply use those medium of the mobile applications to probably interact, send money, receive money. But at the end of the day, if a bank or a government wants to seal and take out the money, they can simply do that. Nothing will stop them. We don't control that amount of data which is there, or the money that is there in our bank accounts there. Similarly, there has been instances of, let's say, land records, right? We all go to register our houses, and we do a registry in a central repository, where we are at the mercy of those documentation being kept in a isolation, so that it doesn't get harmed or hampered or burned. But for example, in Telangana, there has been instances where the whole land records were burned down because there was a fire in the building, and people lost their land record at that point of time. So that is where the ownership was not ours. Although we own everything, but we cannot claim it as ours. We cannot say that it resides with us. Then came the blockchain, which solved this problem, where everything would be there in a system, but nobody would own it. And that is the concept of decentralization, which was introduced with these blockchains. There has been papers being built on top of this. How do we want to solve this problem of centralization? How does one single authority cannot claim it and then shut us down? If tomorrow, if there are banks which are going kaput, if they chooses to shut down their servers, delete their servers, we will not be able to do anything about it as an individual, because we don't own it. We don't even have a piece of it, right? Except maybe some statements that we get, and if we don't have it, we are done with it. So there has been a lot of decentralization discussions that started early 80s, and then the papers were started being written in 80s and 90s, that how do we solve this problem where people do not, or some group of people do not own it. It can actually be owned by almost everybody who want to participate in that. So came the era of blockchain, where very first paper was written. It said, let everybody participate in the data storage there. So you can go, you can put your server, you can put your hard drive, and then you can replicate the data. And at the end of the day, you will own your data, or at least some piece of your data to start with, which was pretty much how things started, where there were companies who would let you plug in your servers and then replicate the data on your and you can sorry. Okay. So and you could probably participate it or go on this part of the data, but not simply on it. And then with the technology evolution as it happens, then came the system of the blockchains where the data is stored in a way that everything is interlinked, and to own your own data, all you have to do is just put a node there or put a server over there, and everything would get replicated onto your own node. And in case you want to, let's say, send the data or delete the data or not give the data to someone, you will be able to do that. One of the very apt example for this again is getting into the tokenization part of it. So let's say there are loyalty points that we talk about. There has been very big airline loyalty points that has been there, which we earn. When we fly, we get some loyalty points, and again, those are currently in the airline industry, right? Maybe Etihad or Emirates or any of the airlines would own this there. Now, if we can implement this in a way that your loyalty point stays with you and not with them, and then you can use it and they cannot delete it at their own will, is when the true decentralization and the power of ownership comes in there, right? And in this system, for example, if once it's deployed, you participate in that in the nodes. You put your own servers with them, and once you earn your own loyalty points, they are kept with you there. So these airlines cannot expire those points. They cannot delete those points, and then in case a airline goes kaput, they cannot go away with it. There has been more bigger use cases. They can be interlinked, interchanged. They can be centralized loyalty points as well. For example, we have seen that there are alliances being coming up into the industry, into the airplane industry. Like Star Alliance is one of them. So you can actually fly Air India or Lufthansa's, and then you're part of those similar part of it. Now with those, you will have power to use your points on any of the airlines, which right now is not possible, right? You cannot claim your Etihad or Emirates points on on the loyalty points of, let's say, SAS or any of the other, Air India for that matter. But that would actually be able to do that. Right now, the primary blockage is, how do they know how much points anybody has? There is no decentralization. They have their own data, and they don't want to share it, because the moment they share their own data, they know that they're sharing the data of their customers or the flight patterns, and then other airlines can do that. But think about it, if there is a central system or a decentralized system in between, where every airline is participating, and then they are putting in their loyalty points over there, and the user has some sort of a wallet that can show him that he has currently on, let's say, 10,000 flying miles altogether from all of them, and then he can go and redeem them there. That would be a boon for them. Airlines would want to work with them, and the user would be able to own their data themselves. Second thing is, we have all knows the tokenization on the network, which are currently called cryptos, and they are not particularly the bad thing if used the right way, but there has been some negative use cases so far. But if you look at the technology, that device that runs this, the use case of those, where you own your own token and you are responsible for sending the money from your wallet to, let's say, your colleague's wallet there, without having any bank being settled over there. Once the token is minted or the money is minted, and it resides in your wallet or with you in your hand, and the bank has absolutely no power to take it away from you. So that's the power of decentralization, as we say, where not one entity owns this, and you as a customer has absolutely 100% control over it. That's where the blockchain comes in. Next slide, please. So what is blockchain? The blockchain is a distributed ledger technology that it ensures that everything remains secure, transparent, and tamper-proof, right? every single transaction or every single data record that is stored on a blockchain is you can go and look inside it. You can see what exactly, who did the transaction, when the transaction was did. You can actually see from today onwards to the genesis record, or when that money was actually created, and which all wallets or which all users or people it has come through it. So there is a whole web of it. Right now, if I give somebody a 10 rupee note, or if I transfer, let's say, 100 rupees to his wallet, nobody will be able to know from which wallet or which account it is coming from, right? There has been cases where people have got some money via UPI, so they were selling some object. They took some money from some of the accounts, and it turned out that account was using some of the fraud's money, the money that he has earned from doing fraud. So the RBI and everybody is down to their neck to ban those accounts there. They're frozen up account. Their debit freeze accounts are there, and there has been a very good instance quite recently, or very bad I would say, where there was a shopkeeper. He was selling kirane ka stuff, and he took let's say I think 300 rupees from Paytm, from UPI, and his account was immediately sealed the next day, because that 300 rupees actually came from the account which actually did a forgery, right? And that guy would never know about it. And when the government came to him, they froze him. He had no answer, because he's just an old guy, he's just a poor guy, and his whole account was frozen up, and he went through probably weeks of hardship just to get the account opened up there, because everything is centralized. The banks controls this. Everything is being there with the government, that they do that. Now in this case, if this would happen, the getting to know the genesis from which all accounts is pretty easy. So if in case it happens, you can always revert it back. Or more so, there are cases where you can actually blacklist it. The transaction would not happen in your wallets. The technology has evolved to that level. So that is where we say that it is secure, and it is transparent. Even if it happens, you'll be able to know from where all it has come from, and then it is tamper proof. You cannot undo it. Once it is done, it is done. Once you have created a transaction on the blockchain, then it is there forever. For example, tomorrow, if in technology, when I was a developer, there has been many cases where a record used to be created in a database, and it was wrong. There was a bug, and there was a wrong record, and then we would directly go into the system and then correct the data in the production data. We all, and as a technology background, we all have done that, because there has been issues there. Now that's a very probably a sweet case where we were trying to rectify the problem in the system, and then making sure the system doesn't get impacted or the user doesn't get impacted there. But there always a black side or a dark side to this as well. What if in a bank account you have hundreds and millions of rupees, and suddenly you log in and then you see there is 0 rupees. The whole transaction data is completely wiped out. I'm not saying it's going to happen, but there is always a use case, even if there is a 0.0001% chance that one day you will come up and your data is wiped out clean, and you will never be able to prove you have anything over there. This is impossible with blockchain there. All the transactions once done, they stays there forever. And there's a reason to this, why it is not able to do that. First thing is, every transaction, the previous transaction or the previous record is clubbed with the new transaction, and then it builds on a chain. That's the reason it's called a blockchain. You have a block, a transaction of block, and then it is built based on the previous block there that we have. So it will always have some elements or some tail elements of the previous block, and then a new block is created. Similarly, when the new transactions, a new block is created or a new transaction is created on the block, it will always refer something to the previous block of it. So breaking the chain is literally impossible for once. Second, there are multiple data, there are multiple nodes, or there are multiple servers, as we call, exist in the blockchain there. Somebody really have to hack all those servers, at least greater than 51% because of the consensus, which I'll come consensus in a while. They have to hack 51% of all the servers at exactly the same millisecond down to the ticks of it. So we have hours, minutes, seconds, milliseconds, and then we have ticks in the system, which is like thousands of ticks in one second that we have. So you have to be very precise when somebody is trying to hack down the system, or wants to tamper the data with. So that's the reason it's almost impossible in these technological evolutions with blockchain that these data can actually be tampered there. So hence it is called tamper proof there. Then again, each block is a chain which contains a unique record of data, and then once it added to the chain, it cannot be altered or deleted. Transactions on the blockchain are verified by the network of computers. So every time there is a new transaction happening on the system, there are more servers who are trying to validate whether this node, this block, or the transaction that has been created is correct information or not. And how is it a correct information? Whether the block that is being created or the transaction refer to the correct previous block or not, right? So if I'm Rohit and then let's say there is Gaurav, so Gaurav name is being added, he will always have some data associated with Rohit's block there, right? And when more than 51% of the nodes or the network says that yes, this name is being entered into the system and it refer to the previous record of Rohit, it is valid. So the moment it is greater than 51%, it goes through. That means there is a majority of people who are saying that yes, this is the right data, and that's how you validate your transaction, and that is what the consensus mechanism is all about in the system. Apart from that, blockchain, I think there are a lot of benefits of blockchain. It is much faster, it is super secure, it is super efficient, and these days all the blockchains are absolutely carbon neutral. Every blockchain which is coming up now is carbon neutral. There has been a lot of discussion about the negativity on blockchain, that oh, you are putting up a blockchain, you are using a lot of resources of earth, you are putting a lot of carbon footprints on this on this one. You have to use a lot of electricity, but I think those are the eras when the early eras of blockchain, when Bitcoin was there, or maybe even Ethereum initial. These are the two bigger blockchains which used to consume a lot of electricity and have a very negative carbon footprints over there that used to happen. But now we are moving away from these, so you don't need a lot of computational power at all, as of now. Now computational powers was required so that the moment the transaction comes in, it needs to get validated, and that validation requires a lot of processing by computers, and hence you used to use a lot of electricity, and you used to have a carbon footprints there. But now is not the case, and these are absolutely efficient, right? Taking a transaction or sending, anybody who has ever sent a Bitcoin or a Ethereum on a wallet to wallet would know that a transaction could take few minutes to do that. So these were not scalable solutions at that point of time. But now, the era we are in, it takes a split of a second to have a transaction done and a block finalized there. And that is simply because we are not using the mechanism which needs a lot of computational power. Yes, Miss, I think you had a question, right? It is not. It is not. If you are talking about a public blockchain, so there are multiple use cases. You can have a public blockchain, you can have a private blockchain, you can have a hybrid of them there. So if you're using a public blockchain, I don't think so you really need any hardware processing. These blockchain actually does the work for you. So there are nodes which are available. You can use these nodes to store your data. If you look at it, blockchain does the work of storing your data in an untampered manner, right? And that's all they does. That's what they provide you as a solution. So you still build on your application, but data storage is taken care by these blockchains. So you don't really need to have a massive hardware requirement just to deploy a solution with a blockchain there.
What is this open source? Is it open source?
Everything is open source. You can use Bitcoin, you can use Ethereum, you can use layer ones, their Polygon, Solanas. These are all open source. You can simply go and start building application on top of it. The only thing you need is, as they call it, as a gas fees, right? Which is a very small amount of token that they would charge to store the transaction, and that goes towards the maintenance of the network there. And these are in few cents. Every transaction that you do on a blockchain these days is even half than a cent. You don't really even need a cent to do that. It's in a pointers of cents as well. So you can do thousands and thousands of transactions for maybe half a dollar today in these layers. So they don't cost a lot of it. So you can just put like $5 or $10 worth of token there, and they would just keep on consuming whenever you start storing your data in them. Storing would cost you the money, but retrieving it doesn't cost you money in these on any of the blockchains at all. They are readily available to read. Yeah, next. So let's talk about real life examples of blockchains that we have, right? I think we have talked about banking. I've been raving about banking because we totally believe that banking as an industry has a super potential to use that to streamline their work base. One of the very good examples that I've seen recently is in US, where the banks actually implemented interbank settlements. So what is interbank settlement? I'll just touch base on that for a minute. An interbank settlement is when I pay money to, let's say, my friend whose account is in a different bank. So I'm using a Yes Bank, and my friend is using an HDFC bank, and then he makes a payment to, let's say, somebody else who is using, let's say, Kotak Mahindra Bank for that matter. So now my 100 rupee, I pay him 100 rupees, and then he further pay 100 rupees to his friend, which is in Kotak Mahindra. Now in UPI or IMPS, we see the funds in our accounts immediately, right? That's our account because we have been notified that there is money over it. But within the banking system, within the banking industry, the settlement doesn't happen immediately, right? These are all the ledger entries that moves from one system to another, which are there, and then their internal settlement happens always at probably T+1 or T+2. Now T+ is trade plus 1 day. So if I make a transaction today, the final settlement with the bank may only happen in 24 hours, and probably that's the reason we see that once we make an RTGS or an EFT, the banks tell us that in case there are something going wrong, then you will get your money back in about 24 hours because that is the time when they're actually doing their settlements, right? They are seeing and looking at it at all the transactions that has been initiated, and they are matching it with the other banks for whom the transactions were initiated for, and then if they see that this account doesn't get credited, then they would give the money back into your account, and then that's how you get your money back. So these are called interbank settlements, which take a lot of time there, and I think there are banks in US. What they've done is they've used the blockchain technology among themselves. They deployed a system where all the trades and transactions were stored in blockchain, and it would take probably few seconds to do the settlements in the trades that happens there. So instead of relying on intermediaries like correspondent banks, the blockchain will actually enable them to have settled transaction directly with each other. Right now we all know that when we do the wire transfer from let's say international trade we are doing, right? I'm sending $1,000 to somebody in US. It would actually go through some of the banks, right? For example, JP Morgan Chase is one of the biggest bank who does the settlement there. So even if I have to send somebody money in the first bank in US, it would first go to JP Morgan Chase, and then from there it would go to the first bank in US that is there. So there are hops for money that happens, and with each hop there is a cost associated to this, there is a time associated to this, and then it gets settled to the final bank account, which takes about 24 to 48 hours. So when the money gets transferred, it doesn't get reflected in international trade for about 1 day or 2 days there. Now all these timelines can be reduced if the blockchain can be used, because it's just a mere transaction in a ledger, and all they have to do is just reconcile the ledger in the system, and the money would be aware. Even if you don't remove the intermediary in between, even if you only put the system there, it would literally reduce the timeline that we have, and we are seeing that this has started to happen already there. Now this also reduces the risk of errors. There is absolutely less delays and no frauds that can happen there. So the Monetary Authority of Singapore, as we call the MAS, and JP Morgan, they have already, like I was talking about, they've already successfully completed this blockchain-based prototype for cross-border interbank payment. And they've actually demonstrated the potential of blockchain in the financial industry, that the blockchain itself can be very, very beneficial. It can reduce a lot of cost, because every minute the money is not settled, it is adding on to the cost to the bank. They need to reconcile, they need to vet, they need to validate, get stamped, and then the money moves further. But if it is immediately done, it takes out all that headache of the settlements from the banks there. Next slide, please. So some of the next slide. So what are the benefits of blockchain, right? We all know that it is transparent, it is secured, it is also faster, right? Everything is almost done in split second there. The total cost of transactions are very less. When you use this system, you don't really have to have beefy servers running 24/7 there. That takes down your transaction cost, because there is least amount of hardware cost there. And then it increase the transparency, and then reduce the risk that we have in the system. Next slide. Yeah, some of the more things that have been done on blockchain of recently is there has the JP Morgan Chase is actually leading the implementation from the US side of it there. So they have 400 plus banks currently participating in this interbank informational network that they have created, which is used primarily for settlement there. They're using Quorum, and they're using a private blockchain, right? So all the data is not exactly on a public blockchain that it can be accessed by anybody, but it is in a private blockchain, which is even more secured, and it actually enables them the real-time information sharing and verification among themselves. So that reduces the delays in the system. HSBC has been they have also initiated the digital vaulting system on the blockchain. They actually use the blockchain to settle securities transactions, right? Not the commercial banks or the money, but the securities transaction that they do. And they are real-time, they have real-time access to these data, and then it actually improves their transparency. So HSBC themselves were able to get benefited from these data when they knew what exactly is happening. They don't really have to wait for trade to get over, the trade times to get over, and then they have to settle those one. So they were trying to reduce the settlement time from days to few hours, which they have been able to. DBS Bank is another bank which have used blockchain-based platform on their trade financing. So they use the ledger technology to automate their trade financing process, and they also provide real-time visibility and tracking of trade transactions there. Next, please. All right. So everything is good about blockchain, but I'm sure there are challenges. With every good things, there will be challenges there. There is when we talk about blockchain and the ecosystem which is built on top of the blockchain, that is where the challenges start coming in. The regulatory problems, uncertainty comes in, and for right causes as well. We know that with blockchain, when they provide certain use cases, it immediately turns out to be a tokenization, and then it becomes a crypto, and then it becomes a parallel currency in itself, an economy in itself, which is completely wrong per se. So we don't endorse that, and hence regulating something of that magnitude is pretty difficult to do that. Then again, the interoperability, there are so many blockchains as we speak. We have Solana's, Avalanche, we have Polygon, we have Ethereum, we have XTC, there are so many blockchains in the world that you can just pick one, and then if your counterparties, or if you want to enhance, it becomes a nightmare, because your data resides in one, and it is not there available on other blockchains. So if you have a solution based on Avalanche, I have a solution based on Ethereum. Getting a data among both is right now very difficult to do that. Second is a bit of scalability as well, because right now we are seeing there are large volume of transactions that get that are hitting the network there, and there are certain blockchains which are actually facing this scalability problem, right? The blockchains have a transaction record of about, let's say, up to 2000 transactions per second. So the best blockchain that we have seen is about 4,000 transactions per second that they can take there. So one of the scalability problem is the transaction speed per second. We started with about one transaction in few seconds to now we are at about 4,000 transactions per second. So we are improving. I think this is one of those limitations that can be challenged and can be solved. But as of now, we are seeing these transactions there. And when we talk about these numbers, there was a time when Visa did about 24,000 transactions per second. So when the transactions happen, they are pretty much bigger number of transactions that happen. The next slide, please. Yeah, please go ahead.
From the hardware perspective,
Mm-hmm.
is it GPUs are using at the back end?
Not anymore. Not anymore. So GPUs used to be used in early versions of blockchains where you used to have mathematical calculations being required to claim a block or make a block or make a transaction on the network, right? And they used to consume a lot of GPU. I think you must be referring to the era when the mining used to happen, right? Ethereum mining used to happen, Bitcoin mining used to happen there. Now all these mining are basically what these nodes were trying to create a record on the network, right? And to do that, whosoever first solve a certain problem will be given the chance to create the record, and then they will get some sort of a gas fees or some sort of a remuneration in terms of tokenization for them. That is when the GPU was actually needed there. Right now, all the layer ones are basically which are based on Ethereum, right? So we have Bitcoin, then we have Ethereum, and then comes all the layer ones that we have. So Solana and Polygon, they are all are layer one. They are based on Ethereum, call it EVM compatible. They don't need GPU. You don't really need any GPU power to do that. All you need is to have ample computational power available to create a record, just like a normal applications. We have moved away from that. That is the primary reason of carbon footprints that were happening there, right? Because one transaction or one calculation would take few seconds. Generally a calculation should take few milliseconds to do, right? But these calculations were so complex that they used to take about few seconds to do that, and that used to add on to the carbon footprints, energy consumptions that we used to have there.
So this 4,000 per second is the hardware limitation.
No, these are more about the network limitations, not the hardware. Hardware can do wonders. See, whenever a transaction goes into the system, it is not blindly stored like in databases that we are used to, right? They are thoroughly vetted and verified on the system. Like I was talking about, before a block or before a transaction can be stored on a network, it first have to be validated that this is the right transaction. So there are hashes being done, then there are the previous record hash is being taken up and then added on to that, and then a new block is created, and then hash is getting stored over there in the system that happens. So all this takes some sort of a computational power, but it is not as massive. It is probably in few fractions of a percentage of that, and that's the reason you see from few minutes to 4,000 transactions per second that we have been able to achieve now in recent times there. All right, so I think evolution of technology in terms of the solutions that we're talking about. So regulatory frameworks are slowly now being developed, right? We all seen that government have implemented CBDCs now. So they are not worse to the idea of technology solution there. They themselves are implementing them for the betterment. So we've seen the regulatory framework being evolving every single day, and we are pretty confident that as we proceed, the regulatory framework will be more robust, and it would have inclusion for more such technology innovations that we do. Interoperability solutions, like we said, I've got one blockchain, you have got another blockchain, the data resides on my blockchain, but it is not in there. So there are interoperability solution being done. There are Polkadots as one solution that helps doing that. Now scalability solutions are also being developed. Like we said, it is 4,000 transactions, but there are technology which are being developed called sharding and layer 2 solutioning. They will be able to improve the capacity and the speed of the blockchain much further. So I think it's a matter of time when such systems are actually mainstream, and we will move away from the old school technologies of storing everything in a central system or a database to a more robust, transparent, and scalable solution of a blockchain that we have. So I think that's what I have for now. I think after that I would just like to conclude that blockchain technology is actually it's one of those solutions that really have a potential to revolutionize a lot of industry, not only banking or cross-border transactions, but healthcare as an industry, the supply chain as an industry, where things are moving from farmers to the consumer, and then everything that we don't know where that product is coming from. For example, strawberries are being grown in Pune or different part of the country, and we don't know from which farm it is coming from. Is it organic? Is it not organic? How was it transported there? Which month date it was transported? So everything is just lost right now. There, I think these technology do have the solution there, that we can always come back to them and see what exactly that did we ate, what exactly did we bought, how was it grown, how was it manufactured, how was it transported from one place to another, and it will always be there in the system, right? So even few years down the lane, if somebody wants to refute, if we want to go back in time, we want to see how this all happened, that data will still be available. Right now it is not. We are losing so much of data that can actually be used to make better life for farmers, for doctors there. And this is also going to be more efficient and secured, so we'll not have our data loss that happening. Nobody will be able to coin us or use our data without our without our being saying yes to them. Right now we have no say. So once this becomes mainstream, using your data on let's say Facebook for marketing will not be possible. They really you have to say yes to share your data, and then only they will be able to do that. Otherwise they will be completely blacked out there. There are challenges, there are limitations that we are working with, but I think as we progress, as the industry grows forward, there will be silver lining, there will be clear skies for us, and all these challenges as we grow will be able to mitigate that. Thank you. I'm open for questions if anybody has any questions. Yeah, please go ahead.
Yatra is one of the examples that can be used for this kind of technology?
See, the use case are not limited to financial sectors or let's say supply chain or digital yatra, like you're saying. It's a technology which is available for adoption, right? It's up to the developers or the industry standards to pick them up and start implementing them. It's a mere, if you look at it as a blockchain, is a mere place where you can store your data, which can never be deleted and which cannot be used without your permission. You would kind of own it for that matter there. So it's only a decision that government or application developers have to take to use that there. So there is no limitations of it. You can think about any part of life where this can actually fit. There, supply chain is there, healthcare is there, transportation is there, flights industry is there, what date, what time you flew, what you ate in that flight, what time you got off. Everything is stored right now, but they are lost. But these all can be stored in this, which cannot be lost
So
there.
it's basically that it's a form of database as it can be sold.
You have simply oversimplified this. That's a form of database, but I cannot disagree with this. So it is, if you look at it in a simplified fashion, then it is actually doing the job of storing the data, but enhancements are there, right? So storing of a data that you own yourself, right? Storing of data that cannot be deleted, storing of data that cannot be tampered, storing of data that can never be taken away from you. So so that's the kind of an addition that it does apart from storing of a data there.
Thank you.
Thank you. Yes, please.
Can quantum computers crack the blockchain?
Yes. Theoretically, it has been proven. Practically, we are years away from this to do that. So practically, there has been research papers that has proven that quantum computing can break the blockchains there. But the kind of a power would you need to build such kind of network of quantum computers is massive. As per the research that I studied, I don't think so. We have that. We ourselves on this earth doesn't have that much amount of energy to be given to quantum computers to crack a bigger system as an Ethereum there. So theoretically yes, practically probably we may not see that as of now. All right. Thank you. Thank you for listening to me. Have a happy day. Thank you.